Okay, so now we're going to start jumping into 6.4. 6.4 here. And we're going to start looking at properties of logarithms here. Notice as we look through this list, okay, we can see different ways that we can kind of transform logarithms from, like, say, multiplication with number one into addition, or we can do from division into subtraction, or when it has an exponential r, a power of r, we can move that power to the front. These are going to be just added ways in which later on we can use these to start helping us solve logarithmic properties and to also to help solve more complicated equations. And this is going to be mainly done. I'm just going to do a few examples. I'll do like a couple of examples off each one and then let you go into the notes and check the other one. So let's take a look at this first one here and notice that I have log base 4 with 64x cubed square root of y. I do want you to realize that whenever you just kind of look at this part here, realize what you're seeing is 64 times x cubed times the square root of y. That's important because when we look at one of our properties, it says whenever we are multiplying, we can change this to addition. Noticing also we're going to have some exponentials in here, some powers, and we'll also be using some just different properties. So it really will be really important that you kind of just maybe print out this list as you're kind of working through the homework. Write it down, reference it as much as possible. So let's kind of do this A real quick here. I'm going to kind of scroll down here just a little bit and we'll kind of start working our way through this one. So let's rewrite it. I've got A log 4. 64x cubed square root y. Well, let's go and just start slowly but surely rewriting this and realize that since we can change all this multiplication to addition, we can change this into log, always base 4, because that's the base we're working with, log 64, okay, plus log 4x cubed, let me put a parenthesis around that, plus we got another log here, base 4. Now let's go and change that square root of y. Let's change it into its exponential form of y to the 1/2 power. Well, taking a look at this again, let's remember that we have that one rule that says we can take these powers and move them to the front. Okay. Let's also realize that we have another rule that we learned back in a previous chapter, that we could take this guy here and realize we can rewrite him as 4, okay, to the power of 3. Knowing that that's an inverse, realize that one of our rules says when I have a 4 here and a 4 here is the base, I can go ahead and just write that now as simply just a 3. And so this one here will just become 3 plus, let's look here, 3 log base 4 x plus 1 here, I've got this 1/2. I've got log base 4y. And that's about as simplified as we can get this one. Okay. And the reason this helps out is notice, especially for this one, notice it got rid of a log. Okay. We had that one log base 464 turned into just a 3. Well, that's nice. Okay. Because we knew that the log and exponentials, they are inverses of each other. And so therefore that just became the power. Let's do another one here. I'm going to go ahead and do B, okay, because it looks like the harder one. I will leave C for you to look at in your notes. Come here very carefully. Let's look at B and let's start looking at it carefully. First off, realize that we do have a cube root in there. Inside the cube root, we have x times y squared divided by, okay, z to the 4th power. Let's remember that multiplication turns to addition, division turns to subtraction, and powers can get moved out toward the front. So let's just kind of remember that as I start this slowly but surely rewriting process, kind of keep that in mind. Here I have log, and notice it does not have any base listed, so we know this, I was looking at C. We have log base A. Since I was saying it, remember this one right here, that would be a log base 10. I'm going to go ahead and rewrite this one. So I'm going to put a kind of a different little parenthesis here. And notice I'm going to put a parenthesis and put my xy squared, my z to the 4th. And I'm going to change this cube root into its exponential form of 1/3. That's going to help me out because I'm gonna go ahead and use one of the properties I know about with exponentials and say that, hey, one of the first things I can do is take this guy and just move it out front, and that's gonna help us because now look what's gonna happen. Well, I can turn around here and say, hey, how about I do all my stuff? I've got this 1/3 out front. Let's come in here now, put this kind of big here, and let's just start taking care of everything in that parenthesis with that 1/3 kicked out front. Okay, so notice on top, I have log base A. Well, I have this x. That x is being multiplied to that y squared. Multiplication means we're going to turn this into addition. Once again, I've got this log base A, and then I've got this y squared. I will let you know now, because I know there's a square there, I can go ahead and move this guy out front, and I can put a 2 right there. We'll do that on the next step, but I like to go ahead and put my arrows. I'm using division, and so therefore division will turn into subtraction. Once again, I have my log base A, I have z to the 4th, and then once again, I know that that exponent will get moved out front. And let's go ahead and close all this off. And let's do our final rewrite. Kind of scroll down here just a little bit. And notice that we have 1/3. Okay, I have log base A x. Well, that 2 came out front, so I've got a +2 log base A y. This 4 comes out front, so I've got -4 log A z. And there would be my final answer for that one there. Works out very nicely. And like I said, I will leave C up to you to work. But do notice that you do have multiplication happening. That is scientific notation, so will come in handy. Well, using these same properties that we did, let's go the other direction. And then once again, I will do A and B. Now, I would like for you to kind of realize that when doing this, the way I do it, the way other people do it, it will work out as long as you're doing the property and what it says, it's going to work out for you, okay? Watch what's going to happen. I'm going to reverse engineer these. I'm going to pull them all back together, okay? So looking at this carefully, I notice that I have, just going reading over the whole thing, I've got 2 when I'm looking at A here. I've got 2 log base 3 x over 3 minus log base 3 1 over y. Doesn't look like a y there. Yeah. Try to make that look like a y a little bit better. Well, let's realize here that notice I have this 2 here. Well, I can come in here and know that I know this 2 is going to have to go back to that. Okay? So very simply. I also know this, that this negative symbol here is also a division symbol. Also, some people may decide to pull out a power to the -1. It is really up to you. I'm keeping this kind of bare bones. Look at how this is going to look now as I start the slowly but surely rewriting process. I'm going to end up having, let's go this direction with it, log base 3. Well, then notice I'm now going to have, well, that 2 is going to go right here. So I'm going to distribute that 2 inside there and realize that I'm going to have, let me do this in black, x squared over 9. Because remember, that 2 came out front, it was right there, and it got distributed to the inside here. Let's go ahead and kind of show you that mathematically. Remember, this is what it would have looked like, x over 3 over 2, and it just went in there like so. Now I have that over, okay? I still have this division here, so let me go ahead and just write this minus here of this log base 3, 1 over y. Let's make sure that looks like a y this time. Realize that's division, so I can rewrite this once again as log base 3, big parenthesis, x squared over 9, 1 divided by y. When we go up top and look at the math of that, remember x squared over 9 is literally saying divided by 1 over y. But we don't do that. We do x squared over 9 times y over 1. That will finish up this process once we kind of pull all this back together and realize our final answer here will become log base 3. When you do the multiplication here, you get x squared y all over 9. And that would be completely and pulled back together. Let's look at this next one. Notice they're using the natural log. We know on natural log, okay, our base is always an e, okay? That will come in very helpful in the next chapter. So doing this very carefully, doing this very intentional, let's go ahead and start rewriting our problem here and realize we can go and say, okay, I've got this ln of x squared minus 1/2 ln y plus ln of 2. Okay. Being intentional, knowing what we know, let me kind of scroll down here just a little bit here. Let's be very careful looking at the first one. There's really nothing I can do to that first one, but notice the second one. There is this, what we could call a coefficient, or not, but let's just call it that. Let's bring this is an actual power. Let's bring this back. Okay. Notice by bringing that back, what you're bringing back is a negative 1/2. I want you to realize that. Okay. If you just brought back a 1/2, you would still be dealing with a negative, with a subtraction there, which would give you division. Okay. And then notice right here at the very back end, you have ln of 2. So realize also now what I have here, if I rewrote this, let's go and kind of rewrite this. I have the ln of x squared, okay? Taking this negative out, as you can see here, that turns that into a plus ln of what? Y to the what? Negative 1/2. And then plus I've got this ln of 2, this natural log. And realize since I have addition happening all the way across, what do we have there? But we can turn all that into multiplication, which would become ln of x squared times y to the negative 1/2 times 2. Let's be aware of this negative exponent here and realize that when we rewrite this, we can rewrite this like this. The ln of, well, 2 times x squared is going to be 2x squared. That y to the negative 1/2 will go down into the denominator, giving us y to the 1/2 or the square root of y. You can write it either way. It doesn't matter. Okay. Notice that this one over here, if we want to just kind of just show this very, very quickly, what you would have here on this one, if you kind of came down, I'm going to leave C for you, but if you're going to get confused right there, notice on this one, I could have done this. You would have the ln of x squared minus the ln of y to the 1/2 plus the ln of 2. Rewriting the pluses together, I would have the ln of x squared plus the ln of 2 minus ln of y to the 1/2. Realizing that now you have multiplication happening here, division happening right there. So this would still once again turn into the ln of 2x squared square root of y. Notice a couple of different ways to do it. Really your choice. Here we have the change of base formula. Before I jump into this, I'd like to just kind of remind you of something you've learned in the past. Is whenever we were learning how to solve these exponentials, if I gave you something like 2x is equal to 8, I did show you this. Notice that this could be turned into 2x is equal to 2 to the third. We make the exponents equal to themselves, and therefore we get x is equal to 3, and that is how that is solved. But if I showed you something like this, 2x is equal to 9, notice things start to fall apart very quickly. You cannot change that 9 into the same base as that 2 you have as on the left-hand side. So we have a problem. We don't really have a solution way to solve that. We should know by our intuition that that should be 3 and some change. It's going to become a decimal. That is why we have this change of base formula that you're seeing right here. So the change of base formula says this: when you have the log b of x, you take log a of x and you divide that by the log a of b. Okay? So literally all you're going to be doing, let's put it simple, using our example from above, okay? If I wanted to write this one right here as a logarithm, remember, I have the log, my base is going to be a 2, I have a 9, and it's equal to x. So if we want to color code this, we can say, hey, you're going to be dividing this, okay? And then you're going to be putting this guy here on top, okay? And actually, I should just kind of color all that in there if I want to be kind of intentional about everything. So notice what you're actually going to be doing for this one right here. If I wanted to rewrite this one, I could say, to find out the answer, it would be the log 9 divided by log 2, which is nice. And that, just like we thought, that would give us a 3.17 is how that would work. So let's do a couple of these. And like I said, I'll leave C to you. But very simply, you're literally going to do what we just did. Change of base says, hey, let's be honest. I cannot come in here and think of any way to make this work. There is no way for me to change this 15 to where it's going to have the same base as that guy. There is no sort of way I can change the exponents around and do that. So to find my decimal version of this, all I have to do is come in here and go, well, how about I just take the log of 15 and divide it by the log of 7. And when you do that, very simply putting that into your calculator, we'll round to 3 decimal places. We're going to get 1.392. It works no matter what you decide to use, no matter what the base is. But I would like to let you know this. While I'm showing that you're using a log, you can also use the ln of 15 and do ln, or the natural log of 7, and you would once again get 1.392. You can use either one. It does not matter. Showing you that, let's do that on this next one here. Let's come in here and let's just do the natural log of 3. Okay, and then let's do the natural log of 1/2. Either your calculator, you can put 0.5 if your calculator does not have a fraction key. Notice here I get negative 1.585. While you're still learning logarithms, it should become apparent slowly but surely that since this log was in the less than 1, we were destined to get a negative number. Let's do a couple of word problems and then we'll be done. Notice this one right here. It says, this is an application problem here. We have given that the initial I, or I sub 0, okay, is equal to 10 to the power of negative 12 watts per meter squared. What is the intensity of a sound for which the decibel level of the sound measures 156? Round off your answer to 3 decimal places. Realize what they're asking for. Down here, they're giving me a whole formula, but get this, they're giving me the decibel, but they're wanting me to solve for intensity, okay? And so we are going to have to do some manipulation to change this around using what we know about logs now. So let's go ahead and rewrite this whole thing out. Apologize. Rewriting our formula, notice that we're going to have 10 log, okay? I do not know my I, but I do know that here is going to be 10 to the negative 12. Okay, I know that because they give it to me right here. That is what they're telling me to put in right there. I know this whole thing is equal to 156. Well, let's start moving things around mathematically. Let's go ahead and just divide off this 10 because we're trying to solve for I right now. When we do this, notice we get log I 10 to the negative 12 is all equal to, well, divide that off, you get 15.6. So let's also realize that since there's nothing written here, this is log base 10. Okay, which means that if we want to do the inverse of this, we can have this. I put that 10, draw it over there. I've actually got 10 to the 15.6 is equal to I of 10 to the negative 12. We can now multiply these together. We can use cross multiplication. And now, simply solving, we get I. Well, what is it equal to? It is equal to 3,981.072 watts per meter squared. And that's how you would solve one like that. Let's do one more word problem here. One a little trickier. Not really trickier, but you gotta be kind of careful with it. Notice if I have a sample of a certain solution is determined to have, and they give us a little formula here of H sub 3O positive, that is 3 hydrogen atoms with a positively charged oxygen atom, concentration of 1.25 times 10 to the negative 1 moles per liter. What is the pH? Round your answer to 1 decimal place. So we're looking for pH. And they give us a formula of negative log of H3O positive. Let's realize that they give me that and they say your H3O positive is right here. Let me get this back out here, is this guy right there. So let's go ahead and rewrite this as we know that we have a pH that's equal to, well, I've got negative log of, well, what? 1.25 times 10 to the negative 1. Realize we can rewrite this because I have a multiplication happening right here. We know that's going to turn into addition. I do want you to be careful though. Look carefully and realize that you are dealing with a negative log. Okay, so watch how this is going to have to be written as I start this process. So I have equal here negative log of 1.25. Well, normally that would be we're plussing, right? But I can put a big parenthesis, put negative log of what? 10 to the negative 1. Rewriting this again, notice this is going to become negative log of 1.25. Okay? Negative and positive make a negative. And then I got log. Well, notice here I've got 10 to the negative 1. Two ways you can think of this one, but I'd like for you to see this. Realize we have base 10 here, which means that's an inverse there. And so this actually, because this just becomes negative 1, I have a negative 1 here, this is a negative. Realize that what you're going to be left with is equals negative log of 1.25. Negative and negative make a positive, and I get a plus 1. The rest of this I'll be putting in my calculator. I'll do the negative log of 1.25, add 1 to that. When I do that and round that to 1 decimal place, I get 0.9. So my pH is 0.9, which as you can see is very close to hydrochloric acid secreted by the stomach lining. And there you have 6.4. Scrolling back up so you can kind of see what we've been through here. We did the logarithmic properties and a few models. Plenty of examples in your notes to look at. Also, I suggest going in and trying out the third example on each one. So if you have any questions, feel free to email me.